Induction type wattmeter works on AC, DC, both AC and DC, neither AC nor DC. Okay, induction type wattmeter అనేది దేని మీద వర్క్ చేస్తుంది, AC, DC or both AC and DC. ఓకే, మనకి PMMC అలాగే MI అలాగే ఇండక్షన్ అలాగే ఎలక్ట్రోస్టాటిక్ మీటర్స్, ఎలక్ట్రోస్టాటిక్. ఓకే, మనకి పిఎంఎంస్ వచ్చేసి ఓన్లీ డీసీకే వర్క్ చేస్తుంది. వీ కెన్ మెజర్ ఓన్లీ డీసీ. ఓకే, ఎంఐ ఇన్స్ట్రుమెంట్ యూజ్ చేసి బోత్ ఏసీ అండ్ డీసీ. ఓకే, కాకపోతే మనకి ఏసీకి అక్యురసీ అనేది ఎక్కువ ఉంటుంది. ఓకే, అలాగే ఇండక్షన్ టైప్ వాట్ మీటర్ యూజ్ చేసి మనం ఓన్లీ ఏసీని మెజర్ చేస్తాం. ఓకే, అలాగే ఎలక్ట్రోస్టాటిక్ వచ్చేసి ఏసీ అండ్ డీసీ. ఓకే, మనకి క్వశ్చన్లో ఇండక్షన్ టైప్ అంటే ఓన్లీ ఏసీ. ఓకే, ఫ్రమ్ ద ఆప్షన్ ఏ ఈజ్ ద కరెక్ట్ ఆన్సర్. ఓకే, నెక్స్ట్ క్వశ్చన్, వాట్ ఈస్ ద యూనిట్ ఆఫ్ సెల్ఫ్ ఇండక్టెన్స్? ఓకే, సెల్ఫ్ ఇండక్టెన్స్ యొక్క యూనిట్ ఏంటి? సెల్ఫ్ ఇండక్టెన్స్ యూనిట్ వచ్చేసి హెన్రీ. ఆప్షన్ డి ఈజ్ ద కరెక్ట్ ఆన్సర్. అలాగే న్యూటన్ ఈజ్ ద యూనిట్ ఆఫ్ ఫోర్స్. అలాగే టెస్లా ఈజ్ యూనిట్ ఆఫ్ మ్యాగ్నెటిక్ ఫ్లక్స్ డెన్సిటీ. అలాగే ఓమ్ ఈజ్ ద యూనిట్ ఆఫ్ రెసిస్టెన్స్ అండ్ ఆల్సో ఇంపిడెన్స్ యూనిట్ ఆల్సో ఓమ్. ఇంపిడెన్స్, ఓకే, ఇండక్టివ్ రియాక్టెన్స్ అండ్ కెపాసిటివ్ రియాక్టెన్స్. ఓకే, ఓమ్ యూనిట్ వచ్చేసి రెసిస్టెన్స్, ఇంపిడెన్స్, ఇండక్టివ్ రియాక్టెన్స్ అండ్ కెపాసిటివ్ రియాక్టెన్స్. ఓకే, నెక్స్ట్ క్వశ్చన్, if the value of magnetic flux is pi and area under the influence of is A, then what is the value of magnetic flux density? Okay, they are asking what is the value of magnetic flux density. Different options are given. Okay, magnetic flux density is equal to flux by unit area. Okay, magnetic flux density is equal to flux by unit area. Here flux is pi, area is A, pi by A. Okay, magnetic flux density can be indicated by B is equal to pi by A. From the option B is the correct answer. Okay, next question, an EMF of 16 volts is induced in a coil of inductance 4 Henry. Okay, L value is given, L is 4 Henry and EMF is 16 volts. Then we have to find rate of change in current. Okay, we have one relation, E is equal to L di by dt. Okay, di by dt is the rate of change of current. Rate of change of current. E value is given, E is equal to 16 volts. L value is given, L is equal to 4 Henry. We have to find di by dt. Okay, 4 1 ja 4, 4 ja 16. Di by dt is equal to 4 I is equal, I unit వచ్చేసి ampere, time units second, 4 ampere per second. Di by dt is equal to 4 ampere per second. From the option E is the correct answer. Okay, next question, which is used for finding force direction? Okay, finding force direction on current carrying conductor. Okay, current carrying conductor యొక్క force direction find out చేయడానికి మనం దేన్ని యూజ్ చేస్తాం? ఓకే, ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్ ని యూజ్ చేస్తాం. ఓకే, ఫ్లెమింగ్ లెఫ్ట్ హ్యాండ్ రూల్. ఓకే, ఫ్లెమింగ్ లెఫ్ట్ హ్యాండ్ రూల్ యూజ్ చేసి మనం ఫోర్స్ డైరెక్షన్ ని ఫైండ్ అవుట్ చేస్తాం. డైరెక్షన్ ఆఫ్ ఫోర్స్. ఓకే, మన ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్లో మనం 3 ఫింగర్స్ని, థంబ్, ఇండెక్స్ ఫింగర్ అండ్ మిడిల్ ఫింగర్ని 90 degrees ఈచ్ అదర్ ఉండేలా పెట్టాలి. ఓకే, ఇలా 90 degrees పెట్టి మనకు థంబ్ అనేది కరెంట్ ఫోర్స్ డైరెక్షన్ని ఇండికేట్ చేస్తుంది. అలాగే ఇండెక్స్ ఫింగర్ అనేది మనకి ఫ్లక్స్ డైరెక్షన్ని ఇండికేట్ చేస్తుంది. అలాగే మనకి మిడిల్ ఫింగర్ వచ్చేసి కరెంట్ డైరెక్షన్ని ఇండికేట్ చేస్తుంది. ఓకే, thumb indicates direction of force. అలాగే మిడిల్ ఫింగర్ వచ్చేసి డైరెక్షన్ ఆఫ్ కరెంట్. అలాగే ఇండెక్స్ ఫింగర్ వచ్చేసి డైరెక్షన్ ఆఫ్ మ్యాగ్నెటిక్ ఫ్లక్స్ ఆర్ డైరెక్షన్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్. Okay, direction of magnetic flux. Okay, in the question they are asking finding the force direction. Force direction ante thumb indicate chestundi. Okay, we are using Fleming left hand rule. Option B is the correct answer. Okay, next question. Permanent magnets are normally made up of. Okay, permanent magnets are made up of alloys having material of all nico ante mixture of aluminum, nickel and cobalt. Okay, alnico is the mixture of aluminum, nickel and cobalt. Okay, from the options, option A is the correct answer. Okay, next question. As the speed of the generator increases, the induced voltage will be. Okay, ఒకవేళ స్పీడ్ ఇంక్రీజ్ చేస్తే ఇండ్యూస్డ్ వోల్టేజ్ అనేది ఇంక్రీజ్ అవుతుందా, డిక్రీజ్ అవుతుందా, రిమైన్స్ సేమా ఆర్ జీరో. ఓకే, వీ హ్యావ్ వన్ రిలేషన్ ఈజీ ఈజ్ ఈక్వల్ టు పై జెడ్ n/60 ఇంటూ p/a. ఓకే, ఓన్లీ స్పీడ్ ఈజ్ వ్యారింగ్. ఓకే, స్పీడ్ ఈజ్ ఇంక్రీజ్డ్. ఓకే, we can also write Eg is directly proportional to n. Okay, if speed increases, EMF also increases because they are directly proportional to each other. Okay, from the options, option A is the correct answer. Okay, next question. A shunt motor is running at 100,000 rpm if the flux is offed. Okay, flux అనేది ఆఫ్ చేశారు. Then what is the new speed? Okay, we have one relation between speed and flux. Speed is inversely proportional to flux. Okay, inversely proportional to flux. We can also write n2/n1 is equal to pi1/pi2. Okay, here n1 is given. n1 is equal to 1000 rpm. n2 we have to find, and flux pi2 is equal to pi1, 2pi1, and flux pi2 is equal to pi1/2. Okay, pi1/2. Now we have to substitute these values here. n2 we have to find. n1 is equal to 1000 rpm, flux pi1, and pi2 is pi1/2 by 2. Okay, pi1 will cancel. n2 is equal to 2 into 1000 is equal to 2000 rpm. Okay, ఓకే, మనకి ఫ్లక్స్ అనేది ఆఫ్ అయినప్పుడు మనకి షంట్ మోటార్ల స్పీడ్ అనేది డబుల్ అవుతుంది. ఓకే, ఫ్రమ్ ద ఆప్షన్స్, ఆప్షన్ ఏ ఇస్ ద కరెక్ట్ ఆన్సర్. ఓకే, ఇఫ్ ఫ్లక్స్ డిక్రీజెస్, స్పీడ్ విల్ ఇంక్రీజ్. ఓకే, నెక్స్ట్ క్వశ్చన్. If the series flux is in the same direction of shunt, okay, series flux and shunt flux directions are same. Okay, then what we call that motor? Cumulatively compound, differential compound, linearly compound, integrally compound or partially compound. Okay, series flux and shunt flux are in the same direction. Okay, there are two types of motors. One is cumulative compound motor and another one is differential compound motor. This is pole. There are two windings. One is series winding. One more winding is shunt winding. Okay. The current direction is like this. Let us assume. Okay. This is series winding. This is shunt winding. Okay, depending on current direction we have to find flux. Okay, apply Fleming's, apply right hand thumb rule. Okay, these 4 fingers indicates current direction. Okay, apply this rule. Okay, flux is in this direction, thumb flux is in this direction. Okay, series flux is in this direction. Okay, this is series flux. Okay, pi SC series flux. Alage shunt flux. Okay, apply right hand thumb rule. Okay, shunt flux also same direction. This is shunt flux. Okay, both are in same direction. Okay, then it is called cumulative compound motor. Cumulative compound motor, compound machine or motor. Cumulative compound motor. Okay, మనకు షంట్ ఫ్లక్స్ అండ్ సిరీస్ ఫ్లక్స్ సేమ్ డైరెక్షన్లో ఉంటే క్యూములేటివ్ కాంపౌండ్ మోటార్ అంటారు. అలాగే షంట్ ఫ్లక్స్ అండ్ సిరీస్ ఫ్లక్స్ డిఫరెంట్ డైరెక్షన్లో ఉంటాయి. ఓకే, షంట్ ఫ్లక్స్ డైరెక్షన్ ఈజ్ లైక్ దిస్ పై SH అండ్ సిరీస్ ఫ్లక్స్ డైరెక్షన్ ఈజ్ లైక్ దిస్. ఓకే, బోత్ ఆర్ అపోజిట్ డైరెక్షన్. అపోజిట్ డైరెక్షన్లో ఉన్నప్పుడు మనం డిఫరెన్షియల్ కాంపౌండ్ మోటార్ అంటాం. డిఫరెన్షియల్ compound motor. Okay, in the question they are given series flux and shunt flux are in same direction, then it is called cumulative compound motor. Option A is the correct answer. Okay, next question. A DC shunt machine develops an EMF of 250 volts at 1500 rpm. Find the mechanical power developed in the armature having current of 50 amperes. Okay, we have to find mechanical power. We know the relation P mechanical is equal to EG generated EMF into armature current. Okay, or torque into omega. Okay, in the question they are given EG is given, EG is 250 and IA is also given, armature current is 50. Okay, 250 into 50 125.00 watts. Okay, P mechanical is equal to 125.00 watts. We can also write 12.5 kilowatts. Okay, 12.5 kilowatts. From the options, option B is the correct answer. Okay, next question. The commutator in DC motor. Okay, commutator oka work enti DC motor la. Okay, commutator will convert AC to DC in case of generator. Okay, alage DC to AC in case of motor. Okay, here in the question they are given motor lo aithe manaki DC to AC convert chestundi. Okay, from the options, option B is the correct answer. Okay, next question. A DC shunt motor is connected with 200 volt supply. It takes a line current of 18 amperes. Okay, line current is 18 amperes and terminal voltage is 200 volts. Then what will be the armature current if shunt resistance is 100 ohms? Okay, we will draw the shunt motor diagram. Okay, this is armature having resistance of RA, armature resistance. This is EB back EMF. Okay, that is motor లో మనకు బ్యాక్ EMF ఉంటుంది. జనరేటర్ అయితే జనరేటెడ్ EMF ఉంటుంది. ఓకే, షంట్ మోటార్ మీన్స్ the winding field winding is in parallel with armature winding. This is RSH shunt field resistance. Terminal voltage is 200 volts. Okay, shunt resistance is 100 ohms. Okay, alage line current is 18 amperes. Here 18 amperes current is coming. Okay, same 200 volts is applied across field winding. Okay, field winding ISH is equal to V by RSH. Okay, RSH V is 200 volts. Okay, resistance is 100, 2 amperes. Field current is 2 amperes. Here armature current IA is equal to line current minus shunt field current. Line current is 18 amperes, shunt field current is 2 amperes is equal to 16 amperes. Okay, armature current is 16 amperes. Okay, from the options, option D is the correct answer. Okay, next question. Transformer with single winding. Okay, transformer with single winding. Okay, transformer lo only single winding e undali. Okay, auto transformer, current transformer, or power transformer, or potential transformer. Okay, మనకి ఆన్సర్ వచ్చేసి ఆటో ట్రాన్స్ఫార్మర్. ఆటో ట్రాన్స్ఫార్మర్లో ఓన్లీ సింగిల్ వైండింగే ఉంటుంది. ఓకే, ఈ ట్రాన్స్ఫార్మర్లో కంపల్సరీ 2 వైండింగ్స్ ఉండాల్సిందే, 2 వైండింగ్స్ ఉంటాయి. ఓకే, ఆటో ట్రాన్స్ఫార్మర్ వచ్చేసి మనకి ఇలా ఉంటుంది. This is primary side. Okay, primary side we have tapping here. This is secondary side. Okay, this is auto transformer. Auto transformer. Auto transformer is having only one winding. Okay, next question. Iron loss of a transformer is expressed by. Okay, iron loss. Okay, iron loss. Iron loss are two types. One is eddy current loss and hysteresis losses. Okay, iron loss is equal to P iron, Pi is equal to Pe plus Ph. Okay, this is iron losses is equal to eddy plus hysteresis. Hysteresis. Okay, okay, iron loss is equal to eddy current loss plus hysteresis losses. Okay, from the options, option B is the correct answer. Iron loss is equal to hysteresis loss plus eddy current loss. Okay, next question. A transformer of 4000 by 400 volts, 100 kVA rating has 1000 turns on secondary side. Okay, N2 is equal to 1000. N2 is equal to 1000. Okay, V2 is equal to 100, 400. అలాగే V1 is equal to 4000. Okay, we have to find N1. N1 is equal to how much? Okay, we have one relation, V2 by V1 is equal to N2 by N1. Okay, V1 and N1 we have to find N1. Okay, N1 is equal to N2 into V1 by V2. Okay, N2 is equal to 1000. V1 is equal to 4000 by 400. Okay, this is 10. We will get N1 is equal to 10,000 tons. 10,000 tons. Okay, from the options, option C is the correct answer. Okay, next question. A transformer core is generally made up of. Okay, transformer core. This is transformer core. Okay, this is winding, transformer winding, primary winding. This is secondary winding. Okay, okay, this transformer core is made up of silicon steel. Silicon steel. Okay, silicon. Why silicon is used? Silicon will reduce iron losses, hysteresis and eddy current losses. Pi is equal to Ph plus Pe. Okay, hysteresis and eddy current losses can be reduced by using silicon. Okay, from the options, option B is the correct answer. The winding is made up of copper or aluminum. Okay, next question. The primary resistance of a transformer is 0.5 ohms and the secondary resistance is 2 ohms. If the turns ratio is 10, find the effective resistance across secondary. Okay, R1 is given. R1 is equal to 0.5 ohms. R2 is equal to 2 ohms. Turns ratio K is equal to 10. Okay, we have to find effective resistance across secondary. Okay, effective resistance across secondary means the primary resistance can be referred to secondary side. This is R02. R02 means secondary, effective secondary resistance. R02 is equal to R2 plus K R1. R2 is 2 ohms. R2 is 2 ohms plus K square. K is 10. 10 square into 0.5. 2 plus 100 into 0.5. Okay, we will get 52 ohms. Okay, R02 is equal to 52 ohms. Okay, from the options, option A is the correct answer. Next question. The torque developed by single phase induction motor is, okay, torque developed by single phase induction motor at the time of starting. Okay, single phase induction motors అనేవి not a self starting motors. Okay, starting torque is equal to 0. Starting torque of single phase induction motor is equal to 0 for single phase induction motor. Okay, starting torque is 0 for single phase induction motor. Option D is the correct answer. Okay, next question. What is the rotor current frequency? Okay, rotor frequency when 3% slip is 3%, 4 pole 60 head, 3 phase squirrel cage induction motor. Okay, we have to find rotor current frequency. Fr is equal to slip times of stator frequency. Slip times of stator frequency. Okay, slip is 3%. Fr is equal to slip is 3%. 3% means 0.03 into Fs stator frequency is 60 hertz. 60. Okay, we will get Fr is equal to 1.8 hertz. 1.8 hertz. Okay, rotor frequency is 1.8 hertz. From the options, option C is the correct answer. Okay, next question. What is the efficiency of induction motor? If the input of the machine is 150 watts and the loss is 15 watts. Okay, we have to find efficiency. Okay, we have efficiency formula. Efficiency is equal to output by input. Okay, efficiency is equal to output power by input power. Input power. Okay, okay, here input is given and loss is given, output is not given. Okay, from input and the losses we have to find output power. Okay, output power is equal to input power minus losses. Okay, by input power. Input power. Now we have all the data. Input power is there, losses is there, and input is there. Okay, input power is 150 watts minus loss is 15 watts by input power. Input power is 150 watts. Okay, options are given in the percentage. Percentage means we have to multiply with 100. We have to multiply with 100. 100. Okay, 53 ja 52 ja. Okay, 150 minus 15 is equal to 135 into 2 by 3. Okay, 3 1 ja 3 4 ja 12, 3 5 ja 45. 45 into 2 is equal to 90%. Efficiency is 90%. Okay, from the options, option A is the correct answer. Okay, next question. The speed of 8 pole 50 Hz alternator is, okay, alternator runs at synchronous speed. Okay, alternator speed vachesi synchronous speed. We have to find synchronous speed. Ns is equal to, okay, P 120 F by P. Ns is equal to 120 F by P. Frequency is given and poles is given. We can find synchronous speed. 120 into frequency is 50 Hz by 8. 8 1 ja 8. Okay, 40, 15. 15 5 ja 75. 750 RPM. Okay, alternator runs at synchronous speed, that is 750 RPM. From the options, option C is the correct answer. Okay, next question. On which factor frequency depends? Okay, frequency వేటి మీద డిపెండ్ అవుతుంది? డైరెక్ట్లీ ప్రపోర్షనల్ టు స్పీడ్ అండ్ నెంబర్ ఆఫ్ పోల్స్, ఇన్వర్స్లీ ప్రపోర్షనల్ టు స్పీడ్ అండ్ నెంబర్ ఆఫ్ పోల్స్, అండ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు బ్యాక్ EMF ఆర్ డైరెక్ట్లీ ప్రపోర్షనల్ టు అప్లైడ్ వోల్టేజ్ అండ్ EMF. We have one formula. Frequency is equal to Pn by 120. Okay, frequency is directly proportional to number of poles and speed. Frequency is directly proportional to speed, and also frequency is directly proportional to number of poles. Okay, from the options, option A is the correct answer, directly proportional to speed and also number of poles. Okay, option A is the correct answer. Next question. If a 4-pole alternator rotates at 1500 rpm, okay, 4-pole alternator rotates at 1500 rpm, the time period of generated EMF is, okay, number of poles is 4 and ns is 1500. Okay, alternator always runs at synchronous speed. Okay, we have to find time period. Okay, time period is equal to 1 by frequency. Okay, now we have to find frequency. Frequency is equal to Pn by 120. Okay, P is 4 and N is 1500 by 120. Okay, 0 will cancel, 4 1 ja, 4 3 ja, 3 1 ja, 3 50 ja. Frequency is equal to 50 hertz. Okay, now the frequency value substitute here. 1 by 50 is equal to 0.02 seconds. Okay, we can also write 20 milliseconds. Okay, from the options, option C is the correct answer. Okay, next question. What is the luminous efficiency of LED connecting living room if 5440 per fixture? That total fixtures are 64 watts. Okay, we have to find luminous efficiency. Luminous efficiency is equal to luminous flux by input power. Okay, luminous flux by input power. Okay, luminous flux is 5440 lumens. 5440 lumens by 64 watts. Okay, 544 by 64, we will get 85 lumen per watt. Okay, 85 lumen per watt. Okay, from the options, option A is the correct answer. Okay, next question. How many lamps of 6 volts are required to make decorative serial of 240 volt supply? Okay, each lamp having 6 volts. Okay, మనకి decorative serial అనేది సిరీస్ లో కనెక్ట్ చేస్తాం. ఓకే, ల్యాంప్, ఈచ్ ల్యాంప్ ఇస్ okay, each lamp having 6 volts. Like this, we are connected number of bulbs in series. Okay, the supply voltage is 240 volts. Okay, we have to find number of bulbs. Okay, number of bulbs into 6 is equal to 240. Okay, 6 1 ja 6, 4 ja 24. Okay, number of bulbs is equal to 40. Okay, from the options, option D is the correct answer. Okay.